Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video, we are going to solve this question 25 that was asked in GATE 2025 chemistry paper, which is based on organic reagents. The transformation involved is oxidation and reduction. So what is the question? The correct option or option of the reagent and reaction sequences for carrying out the following transformation is or are. That means it is a MSQ type of question or multiple select question. That means one or more than one option are correct. So we have to see all the options which one will be giving the desired product. Okay, so first one, what is the reactant? This is cyclohexene. And what is the reagent given? NBS. What is NBS? NBS stands for N-bromosuccinimide. What is the structure? This is the structure of NBS. N-bromo. Okay, this is NBS, and what is the role of this? It gives the source of bromine radical. Okay, it is a source of bromine radical. Okay, radical reaction will take place, and here also it is used for which bromination? Bromination at the allylic position. Okay, because this will break homolytically, and what we will get? We will get a stable allylic radical. Why this is stable? Because of resonance with this double bond. Okay, so basically what will happen? Bromination at this position. Okay, so first step is bromination. Next is aqueous NaOH is used. Okay, and MnO2. So first we use aqueous NaOH. Okay, in presence of water, this is what this is going to be acting as a nucleophile. When base is used, it will act as a, okay, ethanol and base is used, that means it will form ethoxide and it will act as a ethoxide will act as a base, and nucleophilic the elimination reaction takes place. Whereas when aqueous condition is there, that means water is present and NaOH, what will happen? This will act as a what? It will act as a nucleophile. Okay, and it will undergo simple substitution reaction. Okay, OH, and then you do MnO2 oxidation. What will happen in oxidation? This secondary alcohol will be oxidized to ketone. Okay, and then the next one is Birch reduction. Lithium in presence of liquid ammonia. What will happen? This will selectively reduce this double bond. Okay, how it will reduce? It will add electrons and then hydrogen on both the sides, so it will get reduced to alkane. So what we will get? We will get this product. Okay, so option 1 is correct, A is correct. Now let us see B. In B, what will happen? In option B, if you see, first one is MCPBA. What is the role of MCPBA? Metachloroperbenzoic acid. It is used for, if it is a alkene, it is used for what? It is used for converting it into an epoxide or epoxidation. Then they have added a Lewis acid. Okay, BF3 etherate. This is a Lewis acid. Why? Because boron, it is attached to 3 electron withdrawing group, and plus it also has a vacant p orbital. Okay, so it will coordinate with this oxygen. It will donate electrons in the vacant p orbital of boron, and what it will form? It will form a complex plus BF3 minus. Okay, so after this, what will happen? There is no other reagent that is given, so this is not going to be the correct answer. Okay, because we want this cyclohexanone. Okay, after this, what happens? Generally there is some nucleophile that will attack either from this side or from the other side, and the epoxide ring opening will take place. But since there is no nucleophile given, further reaction will not take place. Okay, now the third option. Okay, now option C. First is selenium dioxide. Now what is the role of selenium dioxide? It is again, it is used for what? It is used for allylic oxidation. Okay, and this carbon next to the double bond, this is the allylic position. Okay, the next to that, this is called as homoallylic. Okay, and the carbon forming the double bond, that is the vinylic position. So oxidation at the allylic position, it will form what? It will form allylic alcohol. Okay, and then there is DMP. What is DMP? DMP is also a oxidizing agent. It will convert the secondary alcohol to ketone. What is the structure of DMP? Benzene. It is iodine based reagent. Iodine has 3 acetyl groups. Okay, and then there is a ester. So this is the structure of DMP, and it will convert what? It will convert this alcohol to ketone, secondary alcohol to ketone. And the last step is they've used K-selectride. What is selectride? Basically, it is a derivative of just like NaBH4. Okay, NaBH4, it has Na plus and boron has 4 hydrogen atoms. It is a stronger reducing agent. Okay, so it is more reactive and it will be less selective. Less selective means it can reduce anything. Okay, sodium borohydride. Okay, or similarly lithium aluminum hydride. These reagents are, you can say, more reactive and less selective. What is the meaning of that? They will react with more functional groups. Okay, almost all the functional groups. Lithium aluminum hydride reduces ester, aldehyde, okay, ketones, everything. But what we will do is, here they have done a modification. They will attach a secondary butyl groups. Okay, these are what? These are bulky groups. You can see the size of this becomes bulkier. So now what will happen? It is become less reactive and it is more selective. More selective. Selective means it will react with one functional group and it will not react with another. So this selectride, it will not react with ketone, but it will react with double bond. So what it will do? Selectride, it will reduce only the double bond and ketone will remain as it is. So we got the product. A is correct, B was incorrect, C is also correct. Now last one, D. Now D1, first one is alkene reacting with KMnO4. Okay, dilute KMnO4. Now what will happen? KMnO4, it is called as syn dihydroxylation. Okay, this reaction is called as, it undergoes syn dihydroxylation. Syn means same. From the same side, di means 2 groups. Hydroxy means OH. Okay, so from the same side, 2 hydroxy groups will be attached. From the same stereochemistry, let's say above the plane. Okay, then what will happen? When you add NaIO4, okay, this bond will break and OH will be added on both the sides. Okay, so what we will get? OH, OH, OH and OH. Then 2 OH groups on one carbon is not stable. So one water molecule will be lost, H and OH. Okay, similarly here also water molecule will be lost. And basically what we will get is, okay, and this bond is also broken. Okay, so here we have one hydrogen as well, right? So what we will get? You will get a dialdehyde, CHO CHO. Now in presence of KMNO4, okay, this aldehyde will be further oxidized to carboxylic acid. So this is the final product. So this is the desired product. The answer is no. So option D is also incorrect. Now this last one, when there are two things, when you use OSO4, osmium tetroxide, versus KMNO4, there are two important name reactions. Okay, you might not know the name of this. You can see this slide. When you use sodium iodate and KMNO4, okay, or iodate and ruthenium based oxidation, then there is complete oxidation of the double bond. It will form aldehyde, and then that will be further oxidized to acid. Okay, if it is secondary alcohol, then you will get ketone. This is called Limix von Rudolph oxidation. And when we use a milder reagent, that is OSO4 instead of KMNO4, the reaction stops at the dialdehyde stage. Okay, it will not be oxidized to acid. So these are two important name reactions. So they can directly give you the names and ask you to match the reagents. Okay, such type of questions have been asked in GATE as well as in CSIR net exam. Net exam, they will give you, match the columns, and they will give you 4 name reagent. Okay, 4 reagent names and what exactly that reagent is. So you can remember this. They can ask in some or the other exam. Okay, so what are the final answers? A is the correct answer and C. So the correct answers are A and C. Okay, I hope you have understood all the reagents. Okay, NBS is used for bromination, this is oxidation, then reduction. MCPBA, again this is used for epoxidation. Okay, epoxide formation. DMP is oxidation. SCO2 is also oxidation. This is reducing agent, then this was also oxidation. Okay, thank you.